modes. On a string. Okay, let me take a string. Now what I do is there's a string, I'll connect it between the walls and it's a tout. So a student comes at the middle, what happen? He will pluck it. He will pull it. Pluck means he'll pull down and release. So what happened to this wire? Will start vibrating. A good example, guitar wires. Most of the wired instruments, guitar, sitar, what all we have, no? So 4 or 5 wires are there, no? So you just hold it and pull it and release, no? It will start vibrating. We do get sound. How it is possible? Sir, how it is possible? How do we get a sound? Okay, why to think, why to go till their guitar? Huh? No. I'm searching for paper. Yeah. Okay, now see this. I'm producing sound. I actually I'm speaking. I'm producing sound by how sound came just by waving paper. Ah, sir, you are getting cool breeze. Okay, fine. I'm getting cool breeze. All of you heard sound, some sound you heard. This only if I vibrate in certain way, no, I may get some melodious one. Through paper also I can produce music. The same thing with the string also. So if you take a wire, connect across between 2 points and start vibrating, no, it will generate sound signal. The wire will act like a source of sound. The wire will produce a sound signal. From where the energy will come, an X agent, he will go and he'll plug the wire, he will pull this and release. It will start vibrating. It starts vibrating. It will take certain time to complete one oscillation. No, there's a time period. The reciprocal of time period will be frequency. But the oscillation setup will be like this. So how do I'll get one loop? This wire will start vibrating in a one loop here. This will be the anti-node. This let me not bring that one. You'll get confused. So there's a node. Node we took red color. Node. This is anti-node. So like that, we'll get this one. So what is the length of the rope? I picked up L. Let T be the tension in the rope. Then we know the distance between nodes. What is the distance between adjacent nodes? Should be equal to lambda by 2. So at what frequency it will vibrate? These are the primary questions. So I'll start like this. Let lambda is equal to let L is equal to lambda by 2 or lambda 1. I'll write it. So what is lambda? Lambda is equal to, we know F equal to V by lambda. So this will become lambda 1 will become V by 2F1. So F1 equal to V by 12. What is in turn V? Speed of the wave. But sir, like by just pulling the string, how wave is set up? This is something new, no, for you. Because what I said, okay, you should hold one end of the rope, should vibrate up and down, they'll get a wave. But what I'm saying that a standing wave is set up. When you pull this and release, no, this point starts vibrating up and down, nothing but a timing will come. So wave will go like this, collide, this will go collide, they'll undergo superposition. This is the idea. Don't think that again, it should be like that only. In a guitar, standing waves are produced. Just by at the midpoint, you hold the string, pull it down, or it's called like a plucking. plucking or striking, two things what we do. Plucking means like going and striking it. Plucking means pulling in this one. I'll pull this, then I'll release. Then it starts vibrating. One loop will be formed. So from where the traveling waves are come, that's sufficient. You just pull it and release. No, this point starts vibrating. When this point starts vibrating, it will make other points to vibrate. Energy will flow. Similarly, energy will flow in this direction. So there'll be flow of energy in this direction. They'll get reflected. We'll get a traveling wave moving opposite to each other. They'll undergo superposition. We'll get a standing wave. Got the idea now? So this is what, and what is V? T and mu under root of T by mu. So further this will be 2L. Okay, this is called like a first resonance, or also like a first harmonic, or called as a fundamental tone. So what is the length of the rope? Length of the rope will remain same as it is, L equal to length by 2. Now instead of student plucking this wire at the midpoint, if I pluck it 1/4 length, see then a rule on the guitar that you should strike there only. You can strike wherever you want. No? Let the student strike at the midpoint, also like at the 1/4 of the distance. Then the where you pull this and release, that should be 90 node. Then we'll see what we'll get it. I'll get it two loops. So this will be the lambda 2 by 2. This everything is the length of the rope. No, let me indicate again. You may think that I changed the string. Nothing. The same string. This will be anti-node. This will be anti-node. This will be node. Now you ask question. Sir, this is node. Okay, will accept. Why the wall should be node? Because what is a node? Node is a point which will not vibrate. I think you know in guitar, the way you put a knot to the particular that frame, no, will it vibrate? Screw that one will not vibrate. No. So therefore, the rope where it is connected to rigid wall, it's a node. Node is a point which will not vibrate. So this is a node on a string. This is also a point on a string which is connected to wall. This will become a node. So I do get here two loops here. So what is the length of the first? It will be f2 is equal to v by lambda 2. What is the length equal to lambda 2 by 2? Length of the rope lambda 2 by 2, which is lambda 2. So further lambda 2, what we can write? V by f2, or f2 equal to v by l, or 1 by l under root of t by mu. This can be written as, I adjusted 2 on both sides, or this f2 equal to 2f1, where this f2 is called as second harmonic or first O tone. You can try if you have any, or you can take some string. No, not only you need to purchase guitar, take some thin copper wire, connect between 2 points. No, try to pull it at various points. You can see loop. So, but sometimes I don't see loop. When you rubber band, rubber band will also get because length of string, of course, it should get elongated. Elastic band, thin elastic band, not thick one. Thin elastic rubber band, thin rubber band also you can try this one. Huh? You can see number of loops. But if better take copper string, no, you can see things clearly. Sir, like why this should be anti-node? Okay, you do one thing, put paper here and you pluck it here. This will start falling at certain amplitude. you keep paper, you keep paper here. I think if you keep paper and release it, no, this may for certain amplitude it may lose contact. Okay, now a student, instead of striking here, if he strikes at one third of the length, see there are two things are there. You can strike the string or pull the string and release. Two things are there. And in guitar, what we do? Do we pull or do we strike? Anybody who are any musician who practice guitar, do we strike the string at various points or do we hold string, will pull and release? I think holding the string, pulling down, that much of time will not be there. No, we have to strike the wire at various points. So if I, instead of striking it off length or say one fourth, if I strike it one third, I'll get now three loops. Okay, this will be lambda by, so total length of the rope is how much? Is equal to L. So in this case, L is equal to 3 lambda 3 by 2, and lambda 3 is V by F3. What is F3 is equal to 3V by 2L, or that practically, ma, it's not that something I am doing magic here. You strike at this point, so this will be, see, like, what is the thing? Where you pull this, there should be the antinode. Yeah, I'm going to put my finger here. I'll plug the string. I'll pull down the string at this point. So there's like a, sorry, not one third, huh? One sixth. Sorry, it is one sixth. One third will come here, no? One sixth. Sorry, at one sixth of the length of the rope, if I pull down and release. So where I am pulling down, that should be the antinode. The distance between antinode and node should be that this point should be node. This is lambda 3 by 6, lambda 3 by 6, lambda 3 by 6. Like that, I'll get three loops. Practically, it is noticed. If you want to try it. So not one third. I'm just taking back one third means here. It will be that one here, one sixth. So plug the string at the one third of the length. Sorry, one sixth of the length, one fourth of the length, of one fourth, one sixth, like that. At several points you can strike it. So what we got it, this one F3 is equal to 3F1. So this is called like a third harmonic, or second overtone. Third harmonic or second overtone. So like that, nth harmonic. So we'll have n loops. In nth harmonic, we'll have n loops. There can be n number of loops here. So this will become lambda by n, and the total length of the rope is L. Then what is the resonant frequency will be? n lambda, sorry, this is lambda by 2, no? So n lambda by 2. Distributed adjacent node should be the lambda by 2. Okay, then this should be equal to lambda is v by f. So therefore f equal to nv by 2l, or fn is equal to n by 2l t by mu. These are called as, no, the nth harmonic it is called as. Now look at this. This wire will vibrate where these are the natural frequency of vibration of the wire. I am coming to that one. These are the natural frequency of vibration of the wire. Natural frequency of vibration of the wire means you strike at the midpoint of the wire, it will vibrate with this frequency only. Finish over, not any other frequency. They call like that's why it is called like a normal modes on a string. It is normal modes on a string, that one. Or further we'll call this as resonant frequencies here. So at this particular point only, what happen, the wire what happen will accept the maximum energy. Means I will what I do, I will strike at the, I will hold at the midpoint at the least, so it will start vibrating. Next, afterwards, what do I get a point? 1/3, 1/6. Next, what do we get? 1/8. 1/8 means where do I should go? I should go here, no? 1/8. 1/8. Will I get it? 1/8 of 1/3, 1/6. Next again, this will be how much here? 1, 2. Next 4 loops will come, no? 4 loops will